How do you protect your application data? Do you back up your databases? Maybe a nightly dump, log shipping, snapshots? That's what many teams do. But I want to show you another way. A different approach, one that might actually be a better fit depending on your situation. Don't worry, this isn't some anti-backup brand. I'm not here to start a fight, I just want to expand the toolbox. Many teams stick with traditional database backups. Full dumps, log shipping, snapshots, you know the drill. But they come with baggage. Log shipping? Sure, it's powerful. It works. But it has many moving parts. Database, SSH, system users. Disk layouts need to stay in sync. There are a lot of moving parts, easy to break. VM snapshots? File system snapshots? Fast and easy. But like dumps and log shipping, they leave out one thing. Persistent data outside the database. What about files and other data that lives outside your database? How to keep them in sync? And restoring? Slow, painful, and often all or nothing. These strategies copy data, but they don't understand your state. So here's an alternative. What if you stopped backing up raw storage and started backing up your application state? Imagine lightweight replicas, each holding a restorable copy of your app state, synced at regular intervals. Each replica can pull or receive updates, whatever fits your flow. I prefer pull, push is an option too, your call. A new replica can join without needing special bootstrapping or manual coordination. This is application level backup, and it plays by different rules. The changelog is the heart of this system. It holds a sliding window of changes, enough to meet your recovery point objective, plus a buffer. You can keep full entity snapshots, simple, verbose, reliable. Or you go full event sourcing with deltas, more efficient, but also more complex. Personally, I like full state if the rate of change permits it. If you want to store deltas, make sure to sprinkle in snapshots from time to time. Otherwise, you'd need to keep every change since day one. Add lagging writes to protect against accidental deletes or bad migrations. So what are the benefits of such a system? Want to restore the system? Easy. Rebuild your app state from one of the replicas. Need to restore a single tenant? Also easy. You've got targeted state snapshots. Need to get back online immediately? Also possible. Run the app in read-only mode and start restoring the most critical data first. Then backfill historical or less frequently accessed data. This isn't a dump then restore situation. This can be hot recovery. Want to add more replicas? No big coordination needed. This isn't just a backup strategy, it's a flexible foundation for building safer systems. Replication is powerful, but it amplifies mistakes. If you replicate the wrong thing, you've now backed up the mistake everywhere. And if your changelog logic is wrong, you won't know until it's too late. As it is the case with all backups, until you successfully tested restore, it's not a backup. This isn't a rejection of database backups. It's about using the right tool for your system and your risk model. Application level backups give you flexibility, partial restores, per-tenant state, online recovery, more flexibility. Database backups are still a great line of defense. Maybe they are everything you will ever need. So, how do you handle your backups? Do you already do something like this? Or are you thinking of trying it? Want me to break down how a replication protocol could look like? Or show how per-tenant restore could be implemented? Let me know in the comments below.